Hello and welcome back to the Data Meets Fun YouTube channel. Happy New Year. I hope it's not too late to wish you a Happy New Year. I know it's 20th of January and um, the year is not so new, but this is the first video on our channel, and so I would like to use this opportunity to welcome you into 2025 and to really, you know, wish you the very best. On this channel, we have a lot of ambition and plans for this year. So please stick with us. We'll be starting a series on data engineering. We'll be showcasing full machine learning projects from data ingestion to production. And yeah, I can't wait to do this year with you. So, again, happy 2025 from the Data Meets Fun YouTube channel. Today, I will be teaching you about the types of machine learning. So, machine learning is a very broad field, as you can imagine. Um, but there are two main types of machine learning that I'll be discussing in this video: supervised and unsupervised machine learning. And at the end of this video, you should be able to understand clearly what they are and what differentiates them, and even some examples of these two types of machine learning. So let's get into it. Enough of the intro. I want you to cast your mind back to when you were in high school or when you were in primary school. Remember that after you finish learning, you have to write exams. Yeah, you have to write exams. Um, and usually there are two main ways to test if you really learn the concept. The first method is that you're given a multi-choice question. So you're given a question and you're given options. Out of those options, one is correct, right? And the rest is wrong, or the rest are wrong, rather. But you're given options to guide you. You don't have to think of an option, or you don't have to think of an answer outside of those options that you're given. So if you look at the diagram on the left, you have a question, the answer is A, B, or C. The answer cannot be D or E because that is not in the option. On the other hand, there are some exams that you're given where you have no form of guidance. They tell you define democracy, and there is no option. You have to come up with your own answer. You have to use what you have learned so far. And this sort of naturally applies to the two types of machine learning. When you think about the multi-choice type of question, we can map that to what is called supervised learning, meaning that there is some kind of guidance, there are options. And then when we think of the open-ended question, we can map this to what is called unsupervised learning, meaning that the machine learning algorithm really doesn't have options. It has to sort of come up with its own answer from the data. Let's give it a formal definition. Supervised learning is a category of machine learning that uses labeled data. I want you to not forget that. It uses labeled data to train algorithms to predict outcomes and recognize patterns. Now, the major key to doing supervised learning is that our data sets are labeled. What does it mean for a data set to be labeled? Below is an example of a data set. We have age, sex, BMI, children, smoker, region. This is a data set that is describing individuals, and the idea here is that we want to know how much each individual will spend on insurance. Now, Charges is the label. Label means that there is something, there is at least one variable, one column in that data set that we want to try to predict. Okay, so once we have at least a column, a variable that we want to predict, we say that the data set is labeled. If we have a data set that has 6 columns and we do not want to predict any of these columns, it means we don't have a label. This is the major differentiating factor between supervised and unsupervised machine learning. Okay, now let's continue. In this data set, we have the input and we have the output, right? So the inputs are the the columns or the variables that we would use to predict our label. Now there is a lot of nomenclature, a lot of names we can use to refer to these things. We can call them the inputs, we can call them the predictors, we can call them the independent variables, and we can call them the features. These are some of the names that you would see in the machine learning literature. For our label, we can call it label, of course. We can call it the response. We can call it dependent variable, and we can call it the target. Now, I want us to go deeper into supervised learning. There are also branches or types of supervised learning. So, we've established that supervised learning is a type of machine learning where our data set has a label. But depending on the type of label, we can either be doing classification or regression. If our label is qualitative, we do classification. If our label is quantitative, we do regression. What do I mean by qualitative? If, for instance, we have a problem where our label is yes or no, black or white, 0 or 1, we call this qualitative. And so in that case, we are doing classification. But if our label has a type of numbers, for instance, the example that we saw with the charges, you have 100, 101, 2.5, 0. Those kind of numbers, we refer to them as regression. We refer to that kind of supervised learning as regression. Okay? So far we have said machine learning divided into supervised and unsupervised. Supervised is divided into classification and regression. Let's go one more layer. If we are focusing on classification, depending on the number of quantities or depending on the number of categories in that target, it can be binary or multi-class. If it's a yes or no, if it's a left or right, if it's a 0 or 1, just 2 options, we call it binary classification. Once we have more than 2 classes, yes, no, and maybe, blue, yellow, and green, white, red, and blue, you understand it, it's called multi-class. For instance, if we want to predict if let me think of an example. If we want to predict if a customer is going to default on their loan, that is a binary classification problem, right? Because we would say the customer will default or the customer would not default. If we want to predict if a potential customer will fall under our standard, premium, or classic tariff, 3 options, that is multi-class classification. I want you to already think of some examples because I'm going to be asking you to give me some examples in the comment section. Okay, so we are done with supervised learning. Let's move to unsupervised learning. Unsupervised learning is the natural opposite of supervised learning. With unsupervised learning, we are working with a framework in machine learning where the algorithm has to learn patterns exclusively from unlabeled data. What does that mean? It means that the machine learning algorithm doesn't have any kind of guidance. It has to look into the data and try to identify patterns between these variables. Okay? And I would give us some examples of unsupervised learning. So, unsupervised learning, we could be doing clustering, for instance. If you look at the image on the left, the algorithm will be trying to see, can I place individuals or data samples in the same cluster? Are there samples that have similar values in terms of, for instance, age, BMI, and where they live? This is clustering. There is no label. The machine learning algorithm has to try to figure out these patterns. Association rules. It tries to see if some features go hand in hand. People that buy bread tend to buy egg. That's an association. That's a rule. So that's what the algorithm tries to see if there are things that go hand in hand or are closely, occurring in the data set. And then the final example for unsupervised learning is dimensionality reduction. It sounds like a big word, I know. But basically, the idea here is that if you have a data set with 5 inputs, can we reduce that to 2 inputs or 3 inputs and still preserve the original information? That is dimensionality reduction. So we are reducing the number of inputs and trying to preserve the information in the data. Okay, so these are 3 examples of unsupervised learning. Let's summarize what we have learned today. We said that machine learning is generally divided into supervised and unsupervised learning, and this is based on the presence or the absence of labels in the dataset. If the dataset has labels, we call it supervised learning, and if the dataset does not have labels, we call it unsupervised learning. We saw that supervised learning could be either classification or regression. Classification when our label is qualitative, and the regression when our label is quantitative. Okay, and then lastly, we saw some examples of unsupervised learning. We saw clustering, we saw association rule mining, and we saw dimensionality reduction. And that is the end of today's video. Did you learn something new? Let me know in the comment section. And also, I want you to give me examples, real life examples of these concepts that we've learned. Can you think of a real life example of binary classification, or a real life example of multi-class classification, a real life example of regression, of clustering, of association mining, and of dimensionality reduction? I'd love to see your comments. Don't forget to like this video, comment, share, and please consider subscribing to our channel, because I have a lot of good lessons coming up your way this year. Till I come your way next time, keep having fun with data. Bye.